Okay, welcome back. Today we're carrying on our tour of SAT and ACT maths by looking at imaginary and complex numbers. Now, I remember learning about imaginary numbers for the first time in school, and it was a moment for me where math opened up and suddenly started to seem really exciting, really cool. I remember my teacher said that the shortest distance between any point in the real world passes through the imaginary world. And I still don't really know what he meant by that, but I remember thinking, that sounds really cool. I want to know more about this. So for me, imaginary numbers was a point where I got really excited and really enthused about math. For other people, it's a moment where they check out. They're like, right, okay. At this point, mathematicians, you are just making stuff up. I don't care about this anymore. It's too difficult. I'm out. So I think it can be a real turning point of whether people enjoy the fact that math can be more theoretical, more abstract, more philosophical, more imaginative. For other people, it makes an already frustrating subject all the more frustrating. However, as I hope we're going to get to see in this video, they don't need to be anything you need to worry about too much for the SAT and the ACT. You need to know how to do a few processes with them, have a brief understanding of how I, as an imaginary number, works. But once you get those details down, most of these questions are actually pretty straightforward. Now, this video will tell you everything you should need to know for SAT questions based on complex numbers. For the ACT, sometimes they throw in one or two different things. So I'm going to make another video after this with some more specific ACT complex numbers stuff. SAT folk, if you want to watch it just to get a bit of more of a handle on these things anyway, it could help. You never know what the SAT is going to throw at you, but I'm pretty confident the SAT will just give you these type of questions. And so the following video will deal with ACT related stuff, a few little add-ons, but nothing too major. This is still going to be basically all you need to know for the ACT as well. Okay, so if you're ready, let's just get straight into it. Okay, so let's start with what imaginary numbers are and what is the point of their existence. And so let's start with the idea of the square root of 16. What is the square root of 16? Well, hopefully we know that that is 4. But on the other hand, what is the square root of negative 16? And a first obvious guess might be negative 4. However, we know that minus 4 times minus 4 is also 16. And we've been told probably over and over again by now in maths that you can't square root a negative number. It's not possible. And that's why, because minus 4 times minus 4 is 16. However, mathematicians needed this to exist. They needed there to be a square root of negative numbers. And so they invented it. And that is the imaginary number I. And so if the square root of 16 is 4, the square root of negative 16 is 4i. We have 4 lots of I. And so the square root of minus 36, the square root of 36 is 6, so the square root of minus 36 is 6i, the square root of minus 81 is 9i, and the square root of negative 13, well, this could get really horrible, but let's just call it root 13i. Okay. So that's what imaginary numbers are, and now we just need to know how to do a few operations with them. And so if, for some to start with, if I is defined as the square root of negative 1, one thing we want to think about is what is I squared? And if we square any surd, all we do is we take the surd sign away. So if we had root 2 squared, we would take that root 2 away and we would have 2. And so the same thing here, I squared, if we take that surd sign around, if I is the square root of negative 1, I squared is just negative 1. Then we want to think about I to the power 3. I to the power 3 would be I squared multiplied by I. And if I squared is negative 1, that's going to be the same thing as minus 1 multiplied by I. And if you think about this like any other algebraic term, minus 1 times x will be negative x. Minus 1 times I is just negative I. So I to the power 3 is negative I. And I to the power 4 is going to be I squared squared. And so that's going to be minus 1 times minus 1. Well, we know that minus 1 times minus 1 is just positive 1. So I to the power 4 is 1. And we can think about doing this forever, and it might seem like this is going to be a very long, complicated and boring task, but actually we now have a cycle that's going to go round and round and round, because I to the power 5 is going to be I to the power 4 times by I, which is just 1 times I. So we're back to having I again. I to the power 5 is I. And you see this is going to be a cycle. I to the power 6 is going to be negative 1. I to the power 7 is going to be negative I. And I to the power 8 is going to be 1. And this cycle will just repeat and repeat and repeat. So we could think about, for every power of I that is a multiple of 4, I to the power 8 is 1, I to the power 12 will also be 1, I to the 16 will be 1, I to the 20 will be 1. And so if I asked you what is the power I to the 76, you would think about, okay, is 76 a multiple of 4? Yes, it is. And so I to the 76 is going to be 1. Whereas likewise, any even power of I that is not a multiple of 4 will equal negative 1. So I squared was negative 1, I to the power 6 was negative 1, I to the power 10 will be negative 1, I to the 14 will be negative 1, I to the 18 will be negative 1. And so if I asked you what is I to the 62, you could think about, okay, is 62 a multiple of 4? It's not, but it is still an even number, and so I to the 62 is going to be negative 1. Likewise, if I to the 7 is negative I to the 11, I to the 15, I to the 19, I to the 23, all of those are going to be negative I, whereas I to the 5, I to the 9, I to the 13, and so on are just going to stay as I. So we know then that this is a cycle. This is going to be quite useful to know for some questions, but if this is feeling a bit complicated and a bit much, the main thing I really want you to remember is that I squared is negative 1. As we're going to see for coming questions, this is the really, really important one. I squared is negative 1. So that's what imaginary numbers are. Now we need to think about what complex numbers are. And again, it sounds a bit complicated, but a complex number is just a real number plus an imaginary number. So for example, 3 plus 6i, the real part is 3, the imaginary part is 6i, the complex number is 3 plus 6i. Or you could have 12 minus 13i, a complex number with 12 as the real part, minus 13, the imaginary part. Then we need to know a few operations. So firstly, how to add and subtract complex numbers together. This works in a relatively intuitive way. So if we had 4 plus 7i, and we want to add to that 8 plus 14i, just like we would with any algebraic terms, you just add like terms together. So we would do 4 plus 8, which is 12, and 7i plus 14i is going to be 21i. So if we had 5 plus 13i minus 3 plus 10i, again, we're going to have 5 minus 3, which is 2, and 13i minus 10i, which is 3i. So we have 2 plus 3i. Again, with imaginary numbers and complex numbers, we need to be careful, again, just tracking a negative sign as we always need to be. So if we had 2 minus 4i minus 6 minus 16i, firstly we're going to do 2 minus 6, that's going to be negative 4. But then we do minus 4i minus 16i. And again, we have a minus, which is going to become a plus. So minus 4i plus 16i is 12i. So adding and subtracting complex numbers works in a relatively intuitive way. Next, we're going to look at the product of two complex numbers. And if we're really good at quadratics, this process should be really familiar to us. We're just going to have to FOIL two complex numbers together. So if we had 3 plus 4i multiplied by 5 plus 2i, let's FOIL this. We're going to do 3 times 5, which is 15. Then we're going to do 3 times 2i, which is 6i. We're going to do 4i times 5, which is 20i. And 4i times 2i, which is 8i squared. So we're going to get an i squared term. And so if we simplify this, we can have 15 plus 6 plus 20 is 26, so plus 26i. And here's where we need to remember that I squared is negative 1. It's for these questions where this becomes really important. So we have 8i squared. That's the same thing as plus 8 times negative 1. So it's essentially going to be minus 8. So 15 minus 8 is 7. So we're left with 7 plus 26i. Okay, so let's do one more example because this is quite important to get down. If we had 6 minus 2i multiplied by 1 plus 3i, we're going to FOIL this. So 6 times 1 is 6. 6 times 3i is 18i. Minus 2i times 1 is minus 2i. And then minus 2i times 3i is minus 6i squared. So again, combining the I terms, we're going to have 6 plus 16i. And then we're taking away 6 lots of I squared, which is the same thing as 6 times negative 1. So we're going to have 6 minus 6, so that double negative, again, is going to become positive. 6 plus 6 is 12. So we're left with 12 plus 16i. Okay. Now, the last thing we need to do, and this is a really important process to remember, is we need to know how to rationalize complex numbers. So, for example, if we have a fraction like 4 plus 3i divided by 5 minus 2i. Now, we like to be able to write complex numbers as two separate things, a real part and an imaginary part that are completely separate. We want to be able to define exactly how much of this number is real and exactly how much is imaginary. So sometimes we talk about that as writing a complex number in the form a plus bi. However, in the current fraction, we can't really separate this out. We can't completely isolate our real and imaginary part. We could split up the numerator of the fraction, so you could have 4 divided by 5 minus 2i plus 3i divided by 5 minus 2i. We've separated the real and imaginary numbers on the top of the fraction, but the denominator still has an imaginary numbers in both sides, so we haven't completely isolated our real from our imaginary sides. So we need to figure out how to do that. And if you have rationalized surds, or if you're really familiar with the difference between two squares, you might have already figured out how we need to do this. What we need to do is we need to multiply our original fraction by, in this case, 5 plus 2i divided by 5 plus 2i. So you can see what we've done here is we've taken our denominator, we've copied it exactly, except that we've changed the sign from a negative to a plus. And we are multiplying both the top and bottom of this fraction by 5 plus 2i. The reason why we do this is because we're not trying to change the value of the fraction. 5 plus 2i divided by 5 plus 2i is essentially the same thing as 1. So we're just multiplying this fraction by 1. We're not changing its value, but it's a kind of funky one that's going to change how we write the expression. And it's going to be able to help us rationalize this thing as we go through. Okay. So let's start by working with the denominator of the fraction, because that's where the interesting stuff is going to happen. So again, now we're going to FOIL these two expressions. So on the bottom of the fraction, we're going to get 5 times 5, which is 25. Then we're going to get 5 times 2i, so plus 10i. Then we're going to get minus 10i. And lastly, minus 2i times 2i is minus 4i squared. So hopefully you can already see this plus 10i and this minus 10i, they're going to cancel out, they're going to disappear. And this I squared is again going to become negative 1. So we're going to have on the bottom of the fraction, we're actually going to have 25 minus 4 times negative 1. And that's just minus 4. So on the bottom of the fraction, we're going to have 29. So now you can see we've got rid of the imaginary numbers on the bottom of our fraction. We're left with the real number 29. Now we just need to do the top of the fraction. So 4 times 5 is 20, 4 times 2i is 8i, 3i times 5 is 15i, and then 3i times 2i is 6i squared. So again, we can combine the imaginary numbers together on the top. So we have 20 plus 23i, and then again, this I squared is going to become negative 1. So we have 6 times negative 1, which is just negative 6. So we're going to have 20 minus 6, which is 14. So we have 14 plus 23i over 29. And now what we want to do is we can actually pull those two sides of the fraction apart. So we can have 14 over 29 plus 23i over 29. We now have two separate fractions. If we think about this in the form a plus bi, we have a would be 14 over 29, and this 23 over 29 would be b. And that will be us writing it in the form a plus bi, otherwise known as rationalizing a fraction. And so all I want you to take away from this is whenever you have a fraction with complex numbers in it, if you have a sum on the bottom of the fraction like 2 plus 3i, you would need to multiply both sides by 2 minus 3i. You just take the denominator of the fraction, change the sign around, and multiply top and bottom by that. It's a super common process. And if you have that down, then you can just solve these questions pretty much automatically by just doing the same process every time. Okay. And that's going to be largely it for complex numbers. I'm going to do another video where I'm just going to stop there. And that's all we need to know for now, especially for the SAT. That's all you need to know about complex numbers. Okay, great. I hope that helped. So SAT lot, you should be free now to go and do some practice questions on imagining complex numbers in the practice tests, and you should know all you need to know. For you ACT folk, again, you mostly have the basics covered, but you might find 1 or 2 questions that do something a little bit stranger with complex numbers, so I'll give you another video coming up, so please watch that next if you want more help with that. If you want any further help, I am a personal tutor. I do give one-to-one lessons online over Skype if you can't find me in person in London or Glasgow. So I can help you wherever in the world you are. If you want to book some lessons, my website address is below. Please do get in touch and I can help you with any point in the exams, the English, the math, the science, the reading, the essays. I can help you with all of that. Obviously, please do like and subscribe if you're finding these useful, and hopefully I will see you next time. Thanks for watching.